Do you guys remember? Do you guys remember when I told you that now the lead instructor is I have to turn in my tests and I have to have like X amount of easy, mostly medium, and then some what are considered hard questions. There are no easies of these ones. These ones are jump to medium right away. Okay? So to give you a feel for how hard the test is going to be, about 60% of it will be as hard as these questions. Cool? But not all these questions, but what they level of difficulty. Okay? All right. So all right. So the goal of these is to integrate when this strategy, you use this strategy when you're taking the square root of squares, like sums or differences of squares, okay? And depending on which one you're going to use, depending on whether you have, for instance, a squared plus u squared underneath the square root sign versus u squared, or and in this case, u is equal to the function and a is equal to a constant. That's actually pretty important. Okay, so if I'm doing the function squared first minus the constant squared is different than if I'm doing the constant squared first minus the function squared. Okay, so on your blue sheet here that you guys have, your little cheat sheet, I actually gave you kind of like some structures to help us think this through. Okay, you will not, I repeat, not get this on the test. You will get it on quizzes. They don't have any rules about quizzes of me giving you formula sheets, but no formulas on tests. Is everybody with me? So both your quizzes will have these two boxes on them. Your test will not. So you'll need to, but you have some kind of scaffolding up to when you need to fully be able to use all of these. Okay. All right. So if I am under the phrase, or if I'm integrating something where it's like a constant squared minus u squared, okay, what we're going to do is some special substitutions to kind of make some stuff make sense here, okay? So what we're going to do is we're going to let my function equal a times sine of theta. In other words, the sine of theta would equal u over a in this particular case, okay? So we're going to kind of look at this from two different perspectives. If I do that, all of a sudden, I'm going to be able to take my u squared out and replace it with a sine theta squared, which I'm going to write as a squared sine squared theta. Which I'm just going to square both of them. Because if I do this, we can use those Pythagorean identities to help us out quite a bit. Okay? So now you guys, if I ask you to simplify this, something we could do is take that a squared out, because they both have it now, right? And when I do that, I get 1 minus sine squared theta. Well, why is that helpful? So now I have the square root of a squared times cosine squared theta. Can I simplify that? It would just equal a cosine theta. What is lovely about this is integrating this isn't that bad. And then I just resubstitute back. Is everybody seeing it? So, now, if I look at this from the picture, if I have u equals sine theta, another way of saying that is if this is my theta, this would be u, and this would be a. Is everybody good? If I use my Pythagorean theorem here, what would I get? A squared minus u squared. What's the cosine of theta? The a squared minus u squared over a, which is so this is a geometric picture of that simple. So we can use, like, I don't care whether you work it out this way to help you see what you need to see versus if you put it all on a picture. And in fact, I think you'll notice that most of the examples I have you do, I tell you to put it on a picture. Is everybody good? And in fact, those pictures can help us see which one we want to use if we always put our constant on the bottom leg of our triangles. Well, hold on. If it's a squared plus u squared, then my constant's got to be my hypotenuse. No. It's on the bottom. Or if it's a squared minus u squared, a would have to be the hypotenuse. Because remember, this is all coming back to Pythagorean theorem. Okay? So whatever is if I have a subtraction one, whichever one is first goes on my hypotenuse. If I have an addition one, my hypotenuse is the plus, right? It's the radical. And then always put your constant on the bottom if you need to or whatever. It's kind of the way to think it through, okay? The reason I'm saying this is you're not allowed that formula sheet, and it's a way to help you think through which one needs to go where. So what I'd like to do is take you through the first example, maybe the second example. So, when I see this, I'm taking the square root of x squared minus 49, yeah? Are you guys with me that two sides of my triangle then would have to be x and 49? Where's the x going to go? Okay. Hold on. I got it. Guys, I either have a squared plus b squared equals c squared, or I could rewrite that. If I needed that to be a subtraction of two things, it might be a squared equals c squared minus b squared, yeah? Is everybody with me? So, if it's a subtraction underneath that square root, the first one is the... Well, when it's a subtraction, it is the hypotenuse every time. Is everybody good? Are you guys with me? Again, my goal in doing this, I've never taught it this way before because I've always given the formula sheet, but now they don't let me give you a formula sheet, so now I have to do it this way. Okay? So, you guys are my guinea pigs on strategies for teaching this without the formula sheet. Does everybody see now why the x has to be the hypotenuse? Okay. So my x is my hypotenuse, and in order to make this make sense, okay, the other one is always going to be your bottom side. Okay? It doesn't have to be, but we're going to make it that way to help so that we always have the same pattern. Is everybody okay? So I'm going to call this 7. All right. So now, if I had to relate, and keeping in mind, y'all, we want to keep this, I think technically we don't have to, but we want to keep this as either sine, tangent, or secant. Okay? Which one would, between those three, which one would relate the two sides that I have right now? Secant. Okay, so we can say that the secant of theta is x over 7. So likewise, would you guys be comfortable with me saying x is equal to 7 secant theta? Everybody good? And likewise, that would make my one side I haven't labeled yet, x squared minus the square root of x squared minus 49.
Why did you choose theta where you chose it?
I'm always going to put it there.
Okay. Because 7 would not been.
If you put in the top left side a little bit, like on the left side.
Why does 7 have to be next to it?
That's just how.
So, okay. It doesn't. It doesn't at all. It absolutely doesn't.
Okay, doesn't matter. I got it.
So, remember how I said I want to keep things in terms of sine, tangent, and secant in terms of using my trig identities. Okay? All right? So then what matters is this is definitely x. That 7 needs to be an adjacent. So that is really what it is. Everybody okay? Yeah.
If the constant was on the, like, if it was like, the constant was the hypotenuse because it was, like, 7 minus, like, the constant, like.
It was 49 minus x squared.
Like,
Yeah, if it
example
was
2.
49 minus x squared, then what would you put on the bottom?
It would be you flip the,
Would you just
you
flip
flip the 7 and or you flip the 7 and x.
Alright, we'll figure it out here in a second.
Everybody okay? So I'm not trying to. So I also want this fraction. This is a better way of explaining it, y'all. I got a better way of explaining it. I want to rewrite it as x equals the number times a trig function. So I want the bottom of my trig expression to be the constant. Are we good? And so I set it up in a way that would happen. That being said, y'all, this is 3 things to memorize, and they are related to the inverse trig stuff. Okay? Okay. So hold on. Is everybody good with what we have written so far? Okay, great. So my goal is to rewrite this integral with respect to theta instead of with respect to x. Because if I write it with respect to theta, I can substitute a bunch of stuff out. So as I think through that, if I want this to be with respect to theta, I need to get rid of the dx and I need to get rid of the square root of x squared minus 49. Is everybody good with that idea? Okay, great. So if I ask you, well, to get rid of the dx, I could just say, well, what is dx? What is the derivative of 7 secant theta? 7 secant theta tangent theta. Because the derivative of secant is secant theta tangent theta. All right. Then I can say, well, what can I say about the square root of x squared minus 49?
49 secant squared theta minus 49.
Okay, if the algebraic approach would be I take, okay, that means x squared becomes 7, well, I'm squaring it, right? So 49 secant squared theta minus 49, which is now the square root of 49 times secant squared theta minus 1. Is everybody with, just using those identities? Which is 49 tangent squared theta, which is 7 tan theta, yeah? If I want to use my triangle to get there, okay, I can go back and say, hey, can I relate that x squared minus 49 and the 7 using the triangle? How are these two related on the triangle? By tangent. I could also look at that and say, oh, tan theta is equal to the square root of x squared minus 49 over 7. Okay, both are fine. Cool? All right. So now, let's go in and substitute what we know. So the first thing I'm going to sub out is my dx. What did we say that dx was equal to? 7 secant theta tangent theta. D theta. Because that would be pretty important. So I took the dx out. What am I going to put in for? Yeah.
Why is the 7 not in the right one? Oh, wait.
We good?
Like, why is the 7 like 7 tan theta equals, like, why is it not divided by 7?
Say that one more.
Why is it not divided by 7?
Oh, because what we had was that the tangent of theta was the square root of x squared minus 49 over 7, yeah.
Oh, yeah.
And so I'm solving for just this term. So I multiply both sides by 7.
Is that like two different ways to find it, basically?
Yeah,
Oh, that's
100%. 100%. It was, if you want to solve it graphically, which kind of makes a little bit more sense to me, right? But also, there are plenty of people in this room who would much rather solve it this way, right? So it's two competing strategies. The best strategy is the one that makes the most sense to you. This is my favorite thing about math is how many different strategies we can take. And we're all allowed to think differently about what is the easiest. Okay. How are we feeling with what I got so far? Now, you guys, what do I do from here? If I gave you just this, is there some things you might want to do to make this start to look a little bit better? Name one thing. 7 over 7 cancels. Tan theta over tan theta cancels. So now I'm integrating secant theta d theta, which is one of our integration rules we should know, though I'm certain we probably will be studying this one. It is ln of secant theta plus tan theta plus c.
I remember part of it.
How are we feeling? There's only one other thing we got to do.
I forgot the F's to plug back in.
We got to plug back in. Well, what do I know about secant theta?
X over 7.
It is x over 7 plus tangent theta becomes the square root of x squared minus 49 over 7 plus c. Now, you guys, you can absolutely, for instance, memorize. Oh, when this is of the form, this next one is of the form a squared minus u squared. And if you want to just memorize a squared minus u squared is u equals a sine theta. If you want to memorize that, that is absolutely fine. That doesn't work for me. I'm not good at memorizing. I've been teaching this for 4 years and I still went and looked it up. Okay? Because I'm bad at memorizing. Everybody good? So instead, I'm going to say, all right, so here's how Meister would think through this question. Though there are, some of you guys in this room are really good at memorizing and would prefer that. That's a legitimate strategy. Okay? It's just not one that works for me. Okay, so if I were to try to reason this through, all right, I'm looking at this. All right. What do I know? So I need to place, in this case, an x and a 7 on my triangle. What's something I absolutely know? 7. Is everybody good? And I want to write this, and here's my theta, right? I'm always putting my theta, well, I'm always going to put my theta down here, but actually this, as long as we remember, I need to rewrite this as, I'm going to ignore this so that you guys can't see my reasoning. So I'm not cheating. Okay? I'm looking at this as I need to write x over 7 is equal to a trig function. Which one is it? If I'm trying to keep it in sine, secant, and tangent, and if that's the case, my x would go right here. That's my way of thinking about it. Again, if you want to memorize it, great. If you want to find a different way to think about it, awesome. That's the one that makes sense to me. Okay? What does that make my third side? My square root of 49 minus x squared. Ever good? Great. So now, again, I'm going to rewrite. So x over 7 equals sine theta is the same thing as saying x is equal to 7 sine theta. What can we say about the square root of 49 minus x squared? If I know I'm going to relate it back to the 7, right? I could say, one way I could look at it is, how are those two sides related, right? So I would say cosine theta equals the square root of 49 minus x squared over 7. Which means if I were isolating that term, we get 7 cosine theta. That be good? Because I'd multiply both sides. If I wanted to get just that 49 minus x, the square root of 49 minus x squared by itself, I'd multiply by 7. If I want to solve that algebraically, I could do the square root of 49 minus 49 cosine theta. I'm sorry, 49 sine squared theta, which is 49 times 1 minus sine squared theta, which is 7 cosine, the square root of 49 cosine squared theta. It's that, like, again, what makes the most sense is what makes the most sense. If this approach works, great. If this approach works, great. I just want you guys to get it right. All right, so I'm going here, I'm over here, and I'm looking, and I'm saying, all right, at this point, I can take that 49, that denominator, and turn it into 7 cosine theta. Right? We just said that. What else do I need to do that I haven't done yet? If I'm integrating with a theta, I need a d theta. And I also currently have a dx. So somehow I need to turn dx into something with a d theta in it. How do I do that? I take the derivative. What is the derivative of x? Is the equivalent of saying, x is 7 sine theta, so I take that derivative. Are you guys, are we good in terms of the thought process here? So now I have dx equals, I'm not very good at derivatives, but I think the derivative of sine is cosine, so 7 cosine theta d theta. And then I put 7 cosine theta d theta. Holy moly. How we feeling? It's kind of cool. Like, if I made you guys try to sit and integrate what I should have done is assign these problems for homework just for fun. Unless you struggle with them for a little bit. Are we seeing, like, this is a pretty cool strategy? And then I'm going to do some canceling here, right? Whoa, now I'm just integrating d theta. What is the integral of d theta? Theta. You guys are wrong. It's theta plus c. What's the problem with doing theta plus c? I asked you guys to integrate this with respect to x. So, what is theta with respect to x? Theta is arc sine of x over 7. Or, theta is arc cosine of the square root of 49 minus x squared over 7. Or, theta is arc tangent of x over the square root of 49 minus x squared. All of these. Reasonable. Okay? Which is really fun when you check your answers up against Wolfram Alpha or ChatGPT and they tell you something else and you're like, ah, crap. And then you got to remind yourself, like, then you got to go through is this equivalent? Now, y'all, I have zero expectation of mastery of this yet because there's still plenty of ways I can make it a little bit worse or a little bit better, okay? So we will finish this topic on Wednesday after you're done with your quiz. I'm not even going to give you the homework over this yet because I don't want you worrying about it until I want you worrying about the quiz. Here's my